Continuing on, so this is the process for making composite tanks for CNG storage, um, ducting and things like that, inlet duct that we made for Lockheed. So we took an extremely lightweight tooling material made out of MDF material. We machined that and then we poured this tooling material into that. And once it was done, we just took it out and did filament winding around top of that. Or, this was another non-cylindrical type of a shape. And then after the part was made, we just washed out the tooling with ordinary tap water. We made different kinds of so there is also a variety where it is made from a sand type of a material with lightweight fillers. So we made the tooling, I mean it was cylindrical tooling. We made it with cardboard and we just packed it in and we just stepped on top of that, and once it was done, this was what we got. And this was actually um, made for the uh, the mantle tool itself. And this tooling material is called aquacore. The pourable material is called aquapore. So if you Google that, you can find it, and you can find my name attached to that. Um, the other advantage with these tooling materials is that you can actually make sensors and things like that introduced into the tooling, and after the part is done, it will automatically transfer to the inside of your component. So this was the tool insert, and we just put a GPS sensor into that. This was actually, we made an integral wing box. After the part was done, we just washed it out. And we could easily make that, and the sensor actually transferred to the composite itself. We also made some really neat looking parts. So for example, the Kawasaki motorbike guys came to us for making a tooling for a hollow composite wheel rim. They were making it out of metal, and this metal rim was weighing around, I think it was around 900, and I mean about a kilo or something like that. And we made this part in half. We just joined that together and we did a combination of filament winding and fiber layup. And after the part was done, we just washed out the inside of the tooling, and this composite wheel rim weighed something like 180 grams. So 9 times reduction in weight. We made tools and cylinders of different sizes. After the part was done, we just washed out the tooling, and we made, with this material, we made the first all composite aircraft door for the I believe it was for um, the Airbus, just similar to C-130. The Airbus was making that for the German Air Force, and they made it out of that. This was a new ducting for the F-35, and this whole tooling piece is approximately about 16 feet long by no, I mean I think it was around 12 feet long by about 2 feet in diameter. But see the really very complex geometry shape. We made tooling for General Dynamics for some of their hydrazine carriers. And so after the part was done, we just lifted it up and placed it at 90 degrees. So you can see how large this piece is with the help of this tooling material. So this was 4 meters length by 1.5 meters in diameter. We made uh, tanks using these materials, and this is the biggest tank ever produced with this aquacore material, which is about 12 feet long by about 54 inches in diameter. um, we cannot share the actual pictures itself, so I have to show what the only the tooling parts. We made some parts for UAVs for different platforms. So these are all the different tooling pieces made for. I think this is the part for this is the fuel tank for the UAV. So the tooling itself is made from the water soluble tooling material. We made the first CFRP hinge arm for aircraft doors. We made the um, air duct for Bombardier from phenolic resin, and we also made demonstrated that you could make the hatch stiffened panel with these tooling materials. And it took us something like 15 minutes to wash out the inside of this material. And if it had been made from the tooling materials from salt mandrels, it would have taken them something close to 24 hours to wash out that entire tooling piece. So once you make the part, and after the part has been made, you should be able to extract the tool. So your tool should be designed such that it can easily facilitate the extraction. So it needs to have some kind of a taper. It needs to take advantage of the CT mismatch, and so you need to have jacking points, grab points, etc. Okay, so these are uh, I believe there are some videos on this. So this is the tooling, I mean part one and part two, and then how tools can be made from polyurethane and silicone tools and latex tools. So you may, I mean, if you cannot find it, you may be able to find it online. So please go and look at that, and it should give you some ideas about how tooling is made and how important tooling is compared to the part itself. Okay, so that's all I have for lecture 7, and I'm going to stop here.